Hi folks, welcome back. If you've been watching part one of this set of automating TM1 with processes, simplifying the maintenance, you'll probably know, especially if you made it towards the end of that video, that this was coming. So we want to talk this time about using a view to control the input to that TI process. Now, as I got towards the end of that video, I was lamenting not having done it in that case. And the reason that time that I was feeling that way was just that I was on parameters 6, 7, 8 maybe that needed input, needed valid input, right? So I needed a fixed list of attributes to choose from really. Now, the simple pop-up that we get when we execute a process doesn't allow us that level of control to say, oh, this box should be a calendar control, this one should be a pick list, and that sort of thing. But remember that views give us lots of flexibility to control exactly what users enter. Which brings me to the second reason why I might take the same approach of using a view as a source, which is, if I've got a lot of contributors to an application and I need them to contribute updates to a dimension. So for example, one of my property managers is going to enter a new hotel to my hotel's dimension, then a couple of things. A, I definitely want it validated because he could make an error, at any point in that. And two, I might actually want that scheduled. So if I've got a lot of folks contributing to one application, and I know that my process is potentially locking if it's doing metadata updates, certainly dimension members, that sort of thing. I don't want him to just bang away at a process whenever he feels like it. It could be peak times and everybody's in there. I might tell him, look, you put that in, and every hour, every half hour, whatever schedule I want, we'll pick that up and we'll add that to your dimension, and then you can do your input. So up to you how you use it. A couple of good reasons to use it. It may take us a little while, so we better get started.
So here's the process that we were able to build last time if you hung on till the end. You can see we had 8 parameters in total for someone to input. 6 of those were text inputs that required some level of validation, so matching the elements of a dimension or for a particular date and that sort of thing. So I'm going to just burn through some of the basic stuff that we need to create. So build 2 dimensions, we need a cube to store this, set some formats, and we'll just go through that really quickly and then start some of the more interesting stuff. So I'm creating a hotel maintenance dimension, and that's just the name I want to give to what will effectively be my measures, where my pick lists and that sort of thing will be. And it will largely represent our parameters that we were creating in our process. Might add a couple of new ones to that, as we'll see later, but these are the basics that I need to just capture the input. Now I'm going to build a cube, and this cube is going to contain that measures dimension and just a simple list dimension that I already had for data entry. It's literally nothing more than a 1 to 10, however many that I need to allow people to enter new hotels in a particular time period. Now I'm going to set a bunch of formats on that. You guys know how to do all this stuff, copying and pasting and setting formats. I'm going to pause for a moment on date just because we typically look at this as a calendar control, and we might do that, but what we're actually trying to pair this to is a month in our time dimension. So I might just keep this one as a simple subset-based list of dates that we have in our time dimension. Although my other option would be to make this a calendar control and then still just do a test of whether or not the date that they picked falls within the range of a valid date in our time dimension as well. Now, hotel name, we wanted to just be free text. It's a new name. We can't predict what that will be. But we want to select that from a list of known brands. So for that, I'm going to use a pick list. Now, because I only want the leaf level items for my brands dimension to be in that pick list, I'm going to create a subset for that. And I'm actually going to make that a dynamic subset. This is a really simple dynamic subset, so I'm just going to select my leave subset. You'll see down here there's a little browse dialog for an expression. Very simple expression. I want all the level 0 members, and I do want that to be dynamic. What that's going to do is get rid of my totals, which were down here before. You might want something more descriptive than leaves for that, but that will work. So I want to choose a dimension or subset and pick that from my brand leaves. So I'm going to burn through and just create a bunch of others here. You don't need to see this for every subset that we need to create. A couple of quick points. These are dynamic subsets. Dynamic subsets are reevaluated at every point in time when a query is made. So sometimes that's overhead that you don't want. In this case, it's a very small list. I'm really not worried about it. It's only going to happen when someone clicks on that pick list. If I was worried about it, I could convert those into static pick lists and just update them anytime I update the dimension. And the other thing that I wanted to mention here is that I am just using the dimension attribute pick list, which gives me a fair bit of control. I can use dimensions, I can use subsets, so subsets can be dynamic MDX based subsets. Lots of fun I can have with those. But if I wanted the ultimate control over exactly what was happening and potentially create dependencies from one choice to another, then I would have used a pick list control cube, and we'll probably cover that another day. So I think we're ready to take this for a test drive. I'll click save on my dimension. We'll close that and take a look at our cube. So you recall when I executed the process and we got the little pop-up for parameters that I had to remember the name of some things. So not my hotels, because that's free text. I can just execute that. But I had to remember the exact name of the brand. Of course, here I can just choose from a list. Ditto my segments, regions, types, management group, specify my number of rooms, and then our date, which is of course the starting date of the week when we expect that to open. And see how much nicer and easier an experience that is for anyone trying to run this process to add a new hotel. We very quickly step through. We know all our input is valid because we controlled it with the pick lists. No fear of misnaming an attribute and then getting that added or anything like that. Very controlled. So that's all great, but now let's get to the meat of this, which is attaching this cube to the process that we've developed to add those hotels physically. So because we have an existing process that does the work, I've really got two options here of what I could do. So one would be to create another process, very simple one that just reads through my hotel maintenance cube and then calls my add a hotel process. But I'm not going to do that in this case. I'm actually going to step through and just modify my add a hotel process. And because we're using the approach of doing this all in one TI, I'm not going to be passing parameters to it. Moreover, I definitely don't want us prompting for them when it's run. So I'm just going to get rid of all of these parameters, and we'll do these as variables in my prologue. So let's expand all our regions here, blow this up, and get to work. Now there's a valid argument that all I really need to do is change the contents of this variable here, which is named for the parameter that it was. All I need to do is make that point to a cell, and that's pretty straightforward. But really, I hate seeing a naming convention where we're expecting a parameter, but really now we're using a variable. So I'm just going to correct that very quickly. So I'm going to take this parameter and actually change that and change my naming convention so that I see that this is a variable. I'm going to declare it at top, and I like to do this all the time so I know what I'm working with and what the types are. And because I know that this is uniquely named, what I can do is actually a quick find and replace. So here we want to find any case where we have P hotel name and replace it with V hotel name. Quick way for me to update my naming convention in this and make sure that I'm working with the right things. Now I'll move along very quickly through the others, but I'm essentially just replicating the same thing. All of those items that were parameters and ergo named with P so that I could more easily understand that these were values coming to the process, I'm replacing those with a different naming convention. For variables, I'm using V. Declaring these variables up front will make sure that they can be validated against in the process for type. So note that when I've added my rooms here, that is numeric. So if we were using that in a place expecting a string, we would be warned of that. So now I'll just quickly go through and also update all of my names. No need to spend a lot of time on this. I'm just making sure that I'm now using my variables everywhere. If I weren't, I would be prompted that the parameter variable didn't exist because we hadn't instantiated that up front. And the same would be true if one that I declared as a string by saying it was equal to a null string as opposed to a 0, that would also warn me that I'd incorrectly used a type. So now that we've refactored our process slightly to better work with this new approach of using a view, let's have a quick look at that view and see what it is we need to do. The first thing is we have to think in terms of a list of things being entered, right? We allowed data entry for more than one hotel in this, so that means we need to be able to iterate this view to capture all of the input. We'll do that with a loop. Now, loops deserve their own video. There's lots of interesting things that we can do and different approaches to create a loop or a nested loop within a TI process, but we'll just do a quick and easy one here so that you can see how this will work with a view. The other thing that we need to think about here is, although we validated input so that if I enter, say, another new hotel, I'm forced to choose which brand I want, there's actually nothing that prevents me leaving a value null. So that's something that we're going to have to consider now, is how do we test for valid input across a whole new hotel whether or not something's actually been entered. And there are actually two different ways that I could do that. So one is to create a cell, so a new measure here, that says whether or not it's valid. I could do lots of stuff with that, like provide a message saying you haven't entered this value or that value. Very quick and easy if you're used to working with cube calcs and if statements and that sort of thing. But given that we're testing 7 items here, that could be a bit long-winded, so I might just do that in the TI process itself. But first, let's iterate through this cube to see if there's input that we can process. To loop through our list of items, we're going to wrap our existing steps within a while. Now, the while looping approach allows us to repeat a set of actions until a particular condition is no longer true. The most common way of handling that is to have an integer value that gets incremented at each step. And what we're trying to do here is to step through the elements of our list dimension. So when you look again at our hotel maintenance, 1, 2, 3, 4, 5, I want to step through each one of those. And there is both a right way and a wrong way to do this. So less than or equal to 10 would arguably work as long as that list never got longer than 10. A much better approach is to actually just test for the size of that dimension. So I want the dimension size of my list dimension to see if it's less than or equal to this integer I list. I'm going to close that and add some cautions while I enter what is going to complete this. So we're going to perform all the actions between while and end iteratively until this condition is no longer true. One of the easiest mistakes you can make is to forget to ensure that at some point that condition is no longer true. And you get stuck in a loop that will cause the TI process to execute indefinitely. So my standard approach to deal with that and make sure that I don't do it is to always put my end statement and my variable that I'm iterating, that I'm adding to each time I step through, close together, preferably one after the other, where I can see it and make sure it's not caught inside of some if-then condition that isn't going to evaluate to true or something like this. In a simple TI like this, it's not that hard to see, and you might think, who cares? But as you start building larger ones with multiple nested loops, it's very easy to lose sight of that and get stuck inside of one of your conditions. So do watch for that. And if you're worried about other mistakes you've made, like one I just spotted, save often. The compiler will test for a lot of very common, simple things. So it's warning me that I've missed a sign, and that's because I haven't closed my parens here on line 13. Now thankfully we already really have a process here that does the bulk of the work of inserting the element, adding the attributes, specifying the assumptions, all that sort of thing. All we need to do is make sure that we can populate the variables we're using now that are replacing the parameters that we had. And we're going to do that with a whole lot of cellGetS and cellGetN functions. So taking the variables we're using now, instead of making those equal to null, this one is text, so we're going to use cellGetS. We want to get it from our hotel maintenance cube. We want to take that from, now very handy this UI trick here. By prompting for an element, I see which dimension is next in the cube and I see what it's expecting. I know that's my list. So what I actually want to pass there is the member name that corresponds to that. So to get that member name, and again this does have to be a name, we want a string here. While it may be convenient that mine are all numbers and I could just convert the number to string, in your case you will often have things that you actually need the member name. So that's the one I'm going to show you. And we're going to want a new variable to store it. I'm going to call it vlist. This is going to be a string. It's going to match our member name, and I'm going to then do, actually we'll just do vlist equals dimnm from our list, and then the index we're going to pass to get back that name is our I list. That's how we're going to locate that member name. And then I'm going to use that vlist variable here to pass which of these I want to get the string from. The next section is which of those measure values do I want? Well, I want hotel name. I can also see by closing the parens that that's all the dimensions in this cube. I'm done. That's easy. Rinse and repeat many times. So we're going to do the same thing again. We're going to do another cellGetS from our hotel maintenance for vlist, whichever one we're on currently. This time we're going to do it for brand. Terminate that. Get rid of my extra line here and just continue. So again, just rinsing and repeating for each one of these string variables, which represent the attributes that we want to insert. I'm getting them from that existing cube that we've got and just basically populating all of those variables. We'll pause for a second again for vrooms, which is actually going to be a cellGetN, because again we're looking for a numeric value coming from our hotel maintenance cube for whichever vlist item we happen to be on. This time it's going to be number of rooms. Worth briefly mentioning, I could have also created a nested loop to step through each one of these measures and sort of gone list item by list item, then measure by measure. But again, we're going to cover lots of stuff about nesting loops and doing all sorts of stuff like that in another video. And we'll also likely spend more time on conditional statements there. So rather than creating an elegant and robust statement that will test each of these variables, I'm going to do a really simple one so we can finish this off and see if the hotel name is blank. You guys probably know this, but of course I use the @ sign here because I'm testing a string literal value, not setting one, so I do need to specify that. And then if I hit a hotel name that's empty, I want to actually just quit the process. Happily quit, not error, not roll back or anything like that. Just end the process as soon as we hit an empty hotel name. So let's save our process. Have a look at our hotel maintenance. Note well that because we're not doing any validation yet of this data, it could go sideways if we were to leave a segment empty if I'm depending on the attribute in my model logic. Also, we haven't done any validation yet for whether or not two element names are the same. We'll just make this a little bit different. And let's execute our process, which looks to be successful. And then let's validate by looking at our hotel dimension. Our Four Woods brand, which now has 3 new hotels that we've added via that process. So we'll get rid of those, save our dimension. We now have a working process that we could schedule. It's going to pick up updates to a particular cube, iterate through that cube to capture everything, and then perhaps in another video we'll take a look at how we could validate that further, either by cube calculations or with some logic in our TI process. So I hope you guys found that useful. Thanks very much for your time, and happy modeling.